Okay, so this is the part 4 of chapter 7 notes. And we've talked about a couple of properties of logs so far. One of the big ones that's actually not on this page, so I'm just going to add it in right at the top here. We learned that log base b of b equaled 1. And that's not too hard to figure out from the change formula. B to the 1 equals b. Well, that's true, so this equation is correct. We talked about the product one last class, which was if you have a product on the inside of one of the logs, you actually can break it up into, like if this was 50 here, you could break it up into log base b of 5 plus log base b of 10. It's not 15, it's 50 over here. And then a new rule that we haven't talked about, but it's not that hard to kind of figure out. If you're multiplying inside a log, it turns into addition when you split up into two logs. If you're dividing, well, it just turns into subtraction. So it's not that complicated to think of, really. Probably my favorite rule of logs is this one. This one I think comes in the most handy. It's if you have some log, whatever base, of something to a power, that power can actually come down in front. So we'll do examples here of each one. So an example of this one would be, I don't know, log base 2 of 12. You could write that as log base 2 of 2 plus log base 2 of 6. Or you could do 3 and 4, or 12 and 1 if you really wanted to. Here, another example for the division one. Log base 4 of 10. Well, that's the same thing as log base 4 of, let's say, 30. And then you'd have to subtract log base 4 of 3, because 30 divided by 3 is 10. Okay? This one right here, an example would be, like if I had log base 4 of 27. Well, actually, let me choose a different number. Let's say 81. Well, that's the same thing as log base 4 of 3 to the 4th. And since I have something to a power, I can just bring that power right down in front. So that becomes 4 log base 4 of 3. Okay? So let's try some of these problems. In each of the problems for number 1, you're expanding the logarithm and then trying to simplify wherever you can. So we're going to use these rules a ton. So the first one, it's a product on the inside. So I'm going to split that into two log terms. Log base 5 of 25 plus log base 5 of x. Okay, well the one on the right, I can't do anything with it. But the one on the left, the 25, I can. I could write that as log base 5 of 5 squared plus log base 5 of x. Well, I know that when I've got 5 squared, that power can come down in front. And so then this is going to turn into 2 log base 5 of 5 plus log base 5 of x. And log base 5 of 5, that follows this pattern. So that's just 1. So this whole thing turns into 2 times 1 plus log base 5 of x. So there's that answer right there. Let me shrink this down just a little bit. Okay. So let's look at the next one. Log base 2 of y over 32. Well, that one follows the second rule, the quotient rule. If you have something divided by something in a log, it turns into log of the first one minus log of the second one. Okay, so it's going to be log base 2 of y minus log base 2 of 32. Well, 32 can be written as 2 to the something. So it's log base 2 of y minus log base 2 of 2 to the 5th is what 32 is. So I've got a power in here. I can bring that power down in front. So then this becomes, the log base 2 of y stays the same. And the next thing becomes 5 times log base 2 of 2. Well, log base 2 of 2 is 1, because it's b of b. So this is going to be log base 2 of y minus regular 5. Yeah, let's take a look at the next one. So it's another product. No base is listed, so it's base 10, but we can just leave them off. So it's log of 5, whoops, plus log of x cubed. So again, we've got a power. That power can come down in front. So that's going to become log 5 plus 3 log x. And log 5, you can't actually do anything with it if you think about it. It's log base 10 of 5. If I called that, a, let's say, then it's 10 to the a equals 5, but there's no nice a that actually works for 10 to the a equals 5. So this one we just leave put, and this is our final answer right here. If we look at D, ln, remember ln's the same thing as natural log. It's just log base e. But I'll leave ln for now. So it's ln of 4 plus ln of e to the 7th. Well, we got a power. Power can come down in front. So then this is going to be ln of 4 plus 7 ln of e. Ln of e, well, ln of e is the same thing as log base e of e. Well, that means that the base and the thing that's in the log are the same, so that's 1. So this is going to turn into ln of 4 plus 7 times 1, which is just 7. And then that's our answer. Okay, let's keep going. Log of x squared over log of y to the 4th. So it's a quotient, which means we take the difference. Log of x squared minus log of y to the 4th. And then I've got 2 powers. So the 2 comes down in front, and the 4 comes down in front. And so then this turns into 2 log x minus 4 log y. And then we're done. F. Okay. So it's also a quotient. So let's do the quotient part first. Log base 4 of the top, 16x cubed, minus log base 4 of the bottom, y squared. And then let's break this up. This is actually a product. So I can write it as log base 4 of 16 plus log base 4 of x cubed, and then the minus log base 4 of y squared. Okay, well 16 is really 4 squared, so I'll rewrite that one. Log base 4 of 4 squared. And then I can bring this 3 down in front, so plus 3 log base 4 of x. And then I can bring this 2 down in front, so minus 2 log base 4 of y. And then this 2 can come down in front, and I'm left with log base 4 of 4, which is 1. So the 2 is then multiplied by a 1, which is just 2, plus 3 log base 4 of x minus 2 log base 4 of y. And there's our answer. Geez, how many more of these do we have? Okay, a few more. So, log base 9. All right, well, it's really 1, 2, 3, 4 products here, so turn it into four things added together. Log base 9 of 3 plus log base 9 of x squared plus log base 9 of y plus log base 9 of z to the 5th. Well, this one, actually, we can simplify. Let me write it over here on the side, and we'll just work it out individually. I'll call that a. Well, if I rearrange this using the log change to exponential form, it's 9 to the a equals 3. Well, 9 is really 3 squared. So it's 3 squared to the a equals 3. That's the same thing as 3 to the 2a equals 3 to the first. So 2a equals 1, because the exponents are the same now. So a is 1/2. So log base 9 of 3 is 1/2, because it was a. So this thing is 1/2 plus, and then I can bring that power down, 2 log base 9 of x plus log base 9 of y plus 5, because I'm bringing that 5 down, log base 9 of z. Ooh, that's a long one. Okay. You might also notice the 3 is the same thing as the square root of 9. So you could write this as log base 9 of 9 to the 1/2, and then bring that 1/2 down in front. You're left with a 1. Okay, so then h. let's rewrite this. Log base 3 of x to the 1/2. Well, it's a power, so I can bring the power down in front, and I get 1/2 log base 3 of x. And then that one's done, so that one's quick. Okay, and then I got log base 3 of 10x to the 1/3. Like that. All to the 1/3. So I'm going to bring the 1/3 down in front. So 1/3 log base 3 of 10x. Oh, sorry, it's not log base 3, it's just log. Which means base 10. Okay, then I can split this log into using the product rule into a 10 plus an x one. So it's going to be 1/3 and then log of 10 plus log of x. The log of 10, that's really a base 10 there. So this thing is 1. So it's 1/3 1 plus log x. And then if you wanted to, you could split that up into 1/3 plus 1/3 log x. Okay, and then the last few problems here, you're actually combining stuff. So in this one, remember the numbers here have to be the same or else you can't actually combine them. If the bases are different, then you can't use any of these rules. So this one, well, it's a sum of two logs that have the same base. So really I can condense it into log base 4 of the product, 8x. This one, it's a difference, so the first term ends up as the numerator and the last term ends up as the denominator. This one, you can't combine them yet because they have numbers in front. But remember, the numbers in front can come up top and become the powers. So this turns into log of 5 cubed minus log of x to the 4th. 5 cubed is 125, so I'll just rewrite that. 125 minus log of x to the 4th. And now it's a difference, so it's kind of like part B, where the first term ends up as the numerator, and the second term ends up as the denominator. Oh, I forgot to box these, but oh. Okay. 2D, 6 log x. All right, so the numbers in front become the powers. So these go up top. So then this is going to turn into, what here? Log x to the 6th plus log 10 squared minus log of y to the 7th. And then we can multiply the first two together to get one log term. So that's going to be log of x to the 6th times 10 squared. So that's 100 x to the 6th minus log of y to the 7th. And then that's going to turn into log of the first term, 100 x to the 6th over the second one, y to the 7th. Okay. And we've got one last one here. So this 3 can come up top as a power. So I've got log 4 plus, log 3 cubed minus log 12. So let's see, that's going to be log of, and let's just do this all at once. The 4 gets multiplied by the 3 cubed. And then the 12, since it's a subtracting log 12, the 12 ends up on the bottom. Well, we can actually simplify this without having to work out the whole thing. Let me do this. Log 4 times 3 times 2 more 3's over 12. So then the 4 and 3 is a 12, and that cancels with that. So I just get log of 9 for the whole thing. Okay, I hope that helps a little bit. And that's how we use a lot of these various log rules. Okay.